Okay, start our second part of our practical lessons and calculated our task 1.2 about car transport. Now I share this file and we go to use it. Okay, task 1.2. You could write in your paper documents or in your electronic documents. 1.2, it is automobile variant of cargo transportation. It is second variant. We could to calculate the same positions about time, about how much money we need for this delivery, and after it we could to choose what kind of transport is better for us, for our cargo, for our distance of delivery. It is very important. Road transport is characterized by great maneuverability. So it's very mobility kind of transport. We could use technology from door to door, maybe maybe everywhere where it could be possible. No overloading of cargo during transportation. Shorter delivery time, shorter time for initial final operations because on railway transport it is a problem when we preparing for delivery and after delivery we already need to do some final operations before we could to give our cargo to as a manufacturer. So it is a big part of time, and on car transport it is not be possible. And loading and unloading operations also more fast, I think, because it is really not so big part of time when we use wagons. We need to use special infrastructure, special resources for loading and unloading operation to put our wagons in special track when we could use special opportunity and others. So by car transport, it is more simple. Motor vehicles are characterized by low labor productivity and low reliability of work. So we could choose to calculate parameters for this type of transport and find what we could to do with this type. Okay, now the first formula which we could to calculate, it is formula 1.11. It's continuous enumeration of formulas continuous from our previous task, and we could use 1.11 formula now. Please write on your documents T, big T with index TC. It is duration of the trip with cargo in hours. We will find this time in hours, is equal to, and in our numerator, we write such positions as EL with index C. It is distance of cargo transportation by car from the manufacturer to the recipient. It is all distance of delivery in kilometers. Now I find our previous task and we could to find this information. Okay, 1 minute, maybe I open it, 1 minute closed and open it as two documents. Yes.
I have a question.
Okay.
I didn't find this task in our model.
Yes, in our module, no, I connected it no, after our lessons. Yes, it will be in Moodle, and you could use it later, of course. Okay. Okay, I open these documents with our information by the variants. It's the same table, we already used it. And now we used the information about car transport. And we need to find distance of delivery. It is second line from the end. for our variant. Oh, I don't know, maybe variants we need to calculate it. Yes, yeah. Okay. As it is second line from the end, distance of transportation by car from manufacturer to recipient, L with index C in kilometers. And for example, for first variant, it is 270, for second variant, 230. No, and other distance, please calculate it for your variant, which is the last, it is 10 variant, the first, it is first variant. Because it is very long table, I couldn't open it all with the number variant. Okay, if you have first variant, for example, we write 270 and other position, please find it. Mhm. I tried to use these two documents. Maybe I need to connect it, but may try. If you could see, if I open this task 1.2, you could see our formula 1.11. No? Oh no?
Yes.
Yes. Oh, good. Okay, so we could work with this one document. Okay, so we find L with index C, and in our denominator we need to find our speed. It is V with index C. It is average technical speed of the car outside the city, kilometers in hour. Our methodics proposed us to see as information in our appendix D. And now I think that I could to see use this information because it is the same for biggest variant, and I could to see how many kilometers in hour we used by delivery. And when we deliver it outside the city, because it is long distance, we need to depend use this big distance, not only the city territory when we give it, for example, and manufacturer could be located under the city, outside the city. It more possible, yes, than in city, but it could be different locations. We didn't have this information, so okay, maybe we think about all our delivery will be in the outside of the city. So why not? We could use it. Okay, I see you the information about our speed. I stopped maybe on 1 minute and say you the information from our. It is big, very big appendix, and I used it only for our information, what we need. Okay, it is the speed. Mhm. Okay, if it is outside the city and we use it is could be different information about delivery by car or delivery by car train. Car train, it means if we use, for example, one motor part of the car and two, three, or four part with cargo. So it could be car train. But we don't have any information about that it could be possible car train. So, okay, we think that it is only cargo delivery with one wagons with cargo for car. Yes, say about it. Okay, because our distance is very big, it is 200, 300, and 500 sometimes for different variants. We used this speed in outside the city, And for all variants, it will be 44 kilometers in hour. It is about this information. Okay, so we could use in our denominator 44 kilometers in hours. And I continue to share our information. So in our formula 1.11, we could use in our denominator 44 kilometers in hours for all variants. And please calculate it. Leave 2 points after comma, and the result will be in hours. How many hours we need to spend on duration of the trip with cargo. Okay. Yes, and our next formula, because we already know this information about duration of trip with cargo, now we calculated it, and we see in our previous formula 1.10 that first parameters t with index L and unL, it is duration of loading and planned loading operation with one car. We got this information also in appendix, and we could calculate it previous formulas. Okay, let us do it. Our T, big T with index C. It is delivery time by road. About or delivery time by car is equal to. And now I ask you the information about how many hours we need to spend on duration of loading and unloading operation with one car. We discussed that it will be less time for this operation than by railway transport, so we need to find this information. I also stopped sharing on 1 minute and ask you this information from our appendix about this time. Okay. Mm. This time about loading and unloading operation for two types could be possible for two types of works. It can be mechanization works or unmechanization works. We don't have this information about it, but if we don't have this information, I propose that it will be mechanization works, loading and unloading works, and we have such types of cargo as schlag, sand, and other types. It means that it is special types of goods, and we could choose this information about time. In our table, we have time in minutes, and for all variants, because we have the same part, no, the same type of cargo car, it will be seven minutes. Yes, for all variants, it will be 7 minutes. And be careful because we need to use this time in our formula in hours. Because we need to use it in hours, we need to divide it, these parameters by 60 and find this time in hours. Please write is equal to 7 divided by 60, and we have the result in hours, please. 7 minutes, but we need to find this information not in minutes, in hours. So we divided it by 60 and find this information in hours. And plus the result of our previous calculation, our duration of the trip with cargo time. the result of our previous calculation, and it will be delivery time. Okay. The result will be also in hours because it is time. All time now we calculated in hours, and you could leave 2 points after comma. It's enough. Okay. And our next formula for calculation, it is formula 1.12. And we need to calculate the duration of one car trip, taking into account the empty mileage in hours, the same all time we calculated in hours. So we need to find it. Okay, T with index TR, our trip time, is equal to, please write on your paper, and we use our previous calculation. T with index C. It is the result of our formula 1.10. We already did it 1 minute ago. Use this result plus, and if you will be careful, it is our formula L with index C divided by V with index C. We already calculated it. It is our first formula for calculation today, 1.11. Yes? So please add result of our formula 1.10 plus the result of our formula 1.11. And it will be our next result. Okay, I wait you. The result will be also in hours and leave 2 point after comma. What means this calculation, what we do now? It means that the car from point A to point B deliver our cargo, and in point B it is unloading operation and our car is empty. But we need to come back, our car need to come back to the point A for other work for this company and other. So we use deliver it on this way twice. One delivery was with cargo, and second delivery maybe the same. We could name it the same without cargo. So we use this information. First time is more bigger because it is with loading unloading operation with cargo, and the second time without this operation because the car without cargo. It is means this is this information. Okay, and our next formula is formula 1.18. And we need to calculate number of trips per car per day. How many trips one car could do in one day. So please calculate it and write n, little n with index tr, it's trip, mean trips, is equal to, and we use such parameters in our numerator about t, big T with index r. It is duration of operation of the car per day in hours. We need to find this information in our table for our variants because for different variants it could be different time of work of this company, car company of transportation. I opened our table 1.1 and we need to find it is the last line of our table. T with index R, it is duration of car operation per day in hours. And for first variance, first meaning it is first variance, the last it is 10 variance. And please calculate it, the variance, because I am not write it here. Maybe it will be more possible. For first variance, it is 8 hours, second variance, 12 hours, third variance, 8 hours, and different meaning for different variants. Please find your meaning. What she means these times. For example, some company of car delivery could work, for example, 8 hours during the day, from 8 to 16. Some company work 12 hours, from 8 to 20, for example. That means that how many hours during the day our company worked and could deliver our cargo. So we find this information. Okay, I think you find your meaning, and we come back to our formula 1.13. And we divided this time in hours. We used this time in hours as we find in our table, and divided to our T, big T with index TR. It is the result of our previous calculation, formula 1.12. And write is equal to and calculated the result. The result will be in how many trips. So we need to round up the number of trips to big part. For example, we have the result 0.7, so it may be one trips, near one trips. If we have the result 1.5, for example, so we need two trips per day and we need to deliver something and could do two trips. So from point A to point B and come back, and the second trip from point A to point B and come back. So we could do, for example, four trip or it is in both part of our roads means. Okay, calculate please. And round up the number of this trip. Calculated 1 minute. I stopped sharing and come back. If you have some questions about how many tree, please ask. If not, so round up it. So if we find the same parameters in our previous task 1.1 about railway transport, we couldn't have such parameters as number of trips, for example, yes, and other, because it is some different technology of work between different types of transport. In railway transport, we calculated only time of delivery from a station of destination to a station of our finish point. Now we calculated trip in both part of the road. Maybe it will be not so cheap. Yes, because by railway transport we don't need such operation when we use our locomotive, for example, or locomotive and wagons from point A to point B and come back all this type of transport. So maybe it better, better for ecology, better for our situation about how many cost it for our cargo owner and other information. And also we couldn't have time because the railway transport works 24 hours during all year, and car transport companies works, for example, 80 hours or 12 hours during the day and have some day off. It could be Sunday, it could be Saturday and Sunday, or Sunday and Monday sometimes, and it not so so useful for cargo owner maybe, but we could see as a positive position because it could be less time for loading and unloading operation. It could be cargo delivery from door to door, maybe everywhere, because it is not, if it is some mountains territory, of course, we couldn't delivery from door to door, and maybe we used maybe some air transport somewhere where it possible, and other position. No? Okay. So we find some plus and minus characteristics for every type of transport and for everything, maybe, yes, because it is normal, it is reality. Okay, we finish on these formulas today. Okay, we find a number of trips and stopped. And during the next our practical lessons, we continue with money parameters for car transport and calculated them. And I think we could finish this task on our next practical lessons and find all parameters. So I stop sharing my screen and our records.